As a commercial pilot with 24,000 hours, I don't only have hundreds of hours, not thousands of hours, but tens of thousands of hours of this instrument, which is also on the space shuttle, and I'm going to teach you how to use this instrument in this episode. In this issue of Spacecraft Guide, I'm going to continue to teach you how to fly the space shuttle, working again on this instrument in the primary flight display, but the electric version of it on the called the course deviation scale. And when you click on the primary flight display, it takes you to the primary flight display page. And when we come down here, we are going to see in the on the CDI here, we're going to work on the course deviation scale, which are these dots right along here. And when you click on that, it takes you to the course deviation scale page. And as you can see, we are looking, I circled it in orange here, this part of the instrument. And what this does is it displays the deflection indicated, the lateral offset or cross track in nautical miles between the current orbital plane and the targeted orbital plane. The scale for the course deviation updates throughout the ascent from 50 to deviation updates through the scale from 50 to 10 to 1 nautical mile as the cross track decreases. So this will actually, as you get closer to the runway, or your course is if you're going up or you're orbiting, this will change automatically for you. And if you are a paying Patreon subscriber, we're going to go into how that works. It is also displayed digitally to the right, and we're going to talk about that later. It's over here. If we go back, you'll see it's over here, the cross-track error. But we are going to be focusing on just this right here. And as this needle, you see it gives you a reference. This is, of course, deviation indicator. As you move away from the runway here, it's telling you that the runway is to the left of the spacecraft. And what we need to do is turn to the left to do it. So we turn this way. And if we turn to the right, this needle is going to go to that side. Here's another thing too, and we're going to explain this in the next slide. If we keep going straight the way we are, this needle is going to continue to deviate, and we're going to show you why. And that is for our paying Patreon subscribers and our free subscribers. So if you want to know why, if we're going straight, this needle is going to continue to go that way, then sign up for free. That will be downstairs or down below here, and it will tell you how to sign up. And also we will have that on the screen up here on what the address is to go to sign up. So when you click on schematic, it takes you to the navigation page or dedicated display. And it's going to come down here to this course deviation geometry. And in the geometry, you'll see this is the reference point, the end of the runway, and this is the orbital positions. We have A if you're over on this side, B if you're over on this side. We went over this last week for our paying subscribers. And you can see this is the angle to the runway. So this is all, you're in a cone, as us pilots call the cone of confusion. So if you are right along say you're over here, which is pretty much where, or actually on this side, for this the diagram that we had before, for this diagram, you see that it's telling us to go to the left. We're probably right over here. And remember how I told you is if we kept going straight, that needle would keep going over, and that's because this works on an angle. Even though it gives you a distance from the cross track, it actually works on an angle. So if I'm here and I keep going straight, what's going to happen? The needle is going to tell me, hey, you got to turn more to get to the end of the runway, until I get to the point where I'm over here, and the course deviation indicator on the course deviation scale is going to be pegged to the left, which means, you know what? You're in big trouble because you got to come hard to the left to get over that way. So you need, as you get closer to the runway, you've got to be correcting, because this scale, as it gets close, as you get closer, the scale gets more and more sensitive, which is why the scale goes from 50 to 10 to 1 as you're just coming in to land. So this is an explanation on our diagram here for the schematic side for our free members. Now, if you are a paying member, we're going to go more into detail on how those numbers work. So if you are a paying subscriber, which is only $4 a month, that's hardly anything to help me teach you how to learn how to fly the shuttle. And if you are, and you click back on schematics, we are going back to this compass card here, and we are going down to show you, here is the range, and this is that number. This is what's being measured. And again, it shows you, no matter which way you are pointing, that your range is going to be from, well, this should be a straight line going to the end of the runway. But it doesn't matter which way you're pointing. It's always going to tell you the range here. Now, what I have here is the Main Shuttle Crew Operations Manual. This is for the newer shuttle, which has the tubes in it. But right here, we are looking at the horizontal situation indicator and the course deviation scale right here. So it's talking about the ascent displays, and it says the compass card displays the heading with respect to the target insertion plane. So what this is showing you is where it wants to be, where they're putting it into orbit, or the mission defined target. Okay, so that is the place, and that will be defined as 0. So this will be is what you're aiming for. And as we've seen, like in the other display, that this is up, and that this course arrow, which we will talk about later, is at 0, and everything is blocking this rubber line because that's 0. That is the reason why. The compass card and the magenta colored course arrow points directly to 0. So that's when it's going into outer space. And then we were talking earlier that when the orbiter is rolled heads down, the compass card heading increases in a counterclockwise direction, while heads up, it flips and goes in the other direction. Yet the course arrow is always going to stay the same because it's pointing you towards which way you want. Well, it's going to be constantly telling you which way to turn to go to that plane that they are talking about. So thank you again for being our supporters. I'm going to keep going deeper into the documents and other displays as due to the fact that you are donating to me, and for that I thank you.